I'm going to talk to you a little bit about building the data operating system for AI. But before I really begin, before I really get into it, I want to level set with a couple technologies that I think you're going to hear a lot about both in this talk, but also in this conference as a whole. The first is Trino. That is the cute little bunny on the left. That is Commander Bun Bun. That's his official name, in case anybody was wondering. And Trino was created at Facebook to be a SQL query engine that allows you to do really two big things. It allows you to query data anywhere, which means you can federate queries to other data sources, as well as it happens to be the fastest query engine for a data lake. And so Facebook and a number of other internet companies replaced earlier data lake engines with Trino, so Hive or Impala, other query engines you might be familiar with. Trino has really established itself as the predominant open query engine. Commensurate with that, you've got Iceberg, and you're going to hear a lot of Iceberg around this conference as well, because Iceberg is quickly becoming the dominant open table format. Now, why does that matter? We've had open formats for quite some time, going all the way back to the early days of Hadoop, 10, 15 years ago. But what's different this time around is that Iceberg allows you to do updates and deletes, allows you to do time travel, allows you to really do active data warehousing activities out of an open file format. And so the combination of these two technologies allows you to create effectively an open data warehouse, which is a powerful, powerful concept. And many of you may know, this was a natural match. In fact, when Iceberg was first created at Netflix, it was actually created to run Trino, or Presto as it was known previously, queries on it. So these two technologies were literally built for each other. In fact, I had a front row seat to this. My co-founders, of course, are the creators of Presto and Trino. But I was at Teradata at the time while Iceberg was being created. And Netflix was actually a huge Teradata customer. And one of the motivations for creating Iceberg in the first place was to be able to migrate off of that classical traditional data warehouse. Now, Teradata is a phenomenal data warehouse, extremely high performance, extremely highly optimized, but it can get expensive, and it is certainly monolithic. And so the idea of being able to do data warehousing style queries in an open format was the initial motivation for the creation of that format to work with Trino and Presto. So that's a little bit of background. We're going to dive into, and of course this is used by some of the largest internet companies in the world, but we're going to dive into the main topic. So, which is really, how do you create an operating system for data and AI for your organizations? Now, historically, every era of computing has come with it new ways of abstracting and simplifying underlying tasks. When mainframes gave way to client-server, operating systems had to evolve to accommodate simultaneous requests from multiple distributed clients. When personal computers became the predominant computing interface, graphical user interfaces were introduced to enrich that user experience. This is the power of abstraction. Again, that happened again, of course, with mobile and mobile operating systems. And so our belief is that we're entering an era where an operating system makes sense from a data and AI perspective. Now, just to expand on that, I think one of the drivers here is that every company is now increasingly a data company. And for maybe the last 20 plus years, we've said every company is becoming a software company. That is certainly still true. Software is eating the world, as Marky Andreessen famously said. But increasingly, companies are now becoming data companies. And one of the reasons for that is, of course, we know that data volumes continue to explode. Every piece of software today spits out a continuous stream of data exhaust in various forms. AI and ML are only expanding that. And these factors mean that companies need large and economical ways to store this growing volume of data and be able to access that efficiently. In fact, I just read an article in the Wall Street Journal, I think last night, that even the power demands of modern AI technologies and generative AI, it actually outstrips all power capacity that we have on this planet today. And so, being able to become more efficient in the way that we both manage AI and develop our AI architectures becomes incredibly important. The second piece is, as technologies have modernized, that has introduced architectural complexity. We now have more data sources than we've ever had before, and that creates growing cost pressures, growing complexity, and again, the need for abstraction. And as a result, I think what we're seeing is a shift towards all-in-one data platforms that can do everything from the ETL side of the equation, do the data transformations, and as well as consumption. The third piece is certainly that we're seeing data now powering some of the most important applications within an enterprise. This means data is now powering critical processes, not just dashboards. It's powering customer-facing applications, revenue-generating applications, and powering some of the most important critical business decisions made by some of the largest organizations in the world. So how do we kind of simplify all of this and bring this together? Now, again, to go back to the operating system analogy, operating systems, manage computer hardware, software resources, and provide common services for programs. It manages everything from memory and processes and I/O, and allows you to communicate with the computer without having to understand the underlying machine language. And I think similarly, the idea of creating a data operating system makes a lot of sense here with a few different components to it. The idea of a semantic layer, so it's easy to interact with across all the data in an organization. Of course, you need that data processing engine, and then security, governance, data access, and optimization are all critical components of that operating system concept. Now, one of the things that we're talking about today is introducing this idea of an icehouse architecture. There was a blog that we wrote maybe a month ago called the Icehouse Manifesto. You're certainly welcome to find it online. And it was really a recognition that there is now a new data platform that's gaining a lot of momentum, which separates compute and storage and does so in an open way with an open query engine in Trino and an open storage format in Iceberg. And so when you combine these two, you can now create a full warehouse experience, but one that is open, truly open. And so in that blog, we talked about all the necessary components. Now, at its core is Trino and Iceberg, as I mentioned. This blog actually got a lot of attention, and one of the biggest criticism, actually, of the blog was from people who said, we're already doing this. This is not new, this Icehouse thing. We're already doing this, and that's exactly true, which I think actually validates the architecture more than anything else. Of course, it's today used by Netflix, Shopify, Stripe, Apple, a whole host of other companies. And what we're trying to articulate is how do you do this in a fully featured way that enables this operating system, again, for the data within your enterprise. Today, we also announced a whole host of new features that further this concept. So everything from streaming data ingestion, connecting to a Kafka stream, and being able to automatically turn that into Iceberg tables. This allows for near real-time analytics, which, again, increasingly organizations are driving towards real-time. How can I get the freshest possible data? We also announced management of Iceberg tables, the full life cycle of an Iceberg table, everything from creating that table to compacting that table. If you know something about Iceberg, you want to compact all these little files into bigger files to get better performance, partitioning, all these little aspects of how you manage these Iceberg tables. That's now built into our platform as well as lineage, data quality, schema change monitoring, as well as automatically classifying data. We can automatically tag data for PII and other elements. And use those tags within our ABAC, attribute-based access control platform. And we've completely revamped the UX to make it easy to use. So again, all consistent with this idea of a easy-to-use open lakehouse or warehouse. Customers that have had early access to this are seeing great results, significant reduction in compute costs. If you're thinking about a traditional data warehouse like Snowflake, or even a traditional lakehouse like Databricks, you'll see anywhere from 1/10 of the cost to at least 1/2 the cost, leveraging something like the Starburst Icehouse. Best Secret, a large retailer in Germany, talks about being able to skip the data warehouse, being able to query data directly from the lake now using Trino and Iceberg. And Covey talks about, again, the value both from an efficiency and productivity perspective that they're able to find there. If you're interested in learning more or actually trying this out, you're welcome to scan the QR code or stop by our booth. Any member of our team is very welcome to show you how this all works together. Now, I'll walk through a very quick, simple example of, again, how this accelerates development, and then I'm going to invite my friend Subodh from AWS to join me for a discussion. So again, if we think on the left-hand side, streaming ingest provides the freshest data into the lakehouse. From there, you're able to land the data in Iceberg tables, remove that operational burden of having to figure out how to set up and maintain Iceberg tables. Then you have SQL as the common language. SQL continues to be an enduring language that likely will be around forever because it allows you to do data exploration, analysis, preparation, really deploy that medallion-style architecture. Automatic classification protects data privacy. Again, that tagging ability. PII data being exposed to model training and eventual outputs can be a real problem. So how do you protect against that? And then again, industry-leading price performance around the actual processing and analytics of that data. And then last but not least, being able to turn that data into curated data products that can then be shared to both your internal users and even external customers and partners. So with that, let's see. I'm going to skip ahead to the fireside chat. So Subodh, please join me on stage. Thank you, Subodh.
Product launch.
Appreciate it. Now, before we get started, maybe you could introduce yourself so that the members in the audience know what you do for AWS.
Sure. So I head the solution architecture team for Americas for data analytics and AI ML, especially partner focus. Starburst is a great partner of us. We look forward to journey together into great heights.
Absolutely, absolutely. And I think, certainly a very popular trend that we see a lot of is the move from on-prem data lakes, Hadoop and so forth, to S3 as the de facto data lake of the future, so much so that everybody is basically standardized on the S3 interface. One of the questions I wanted to ask you, what are the trends that you're seeing in customers trying to deploy AI? You have the ability to look across tens of thousands of customers. I'm curious what some of the trends are you're seeing.
Sure. So last year changed a lot of things. Last year, February, March timeframe. Before that, most of these models or AIs that were being created were very specific to solution-focused AI, if I could call it. And we'll talk about why shift from that into generative AI as of last year changes a whole bunch of dynamics in that. So everybody knowing the potential of generative AI is trying to adopt it for different use cases. Gen AI is still getting its own maturity in terms of the data, understanding of data governance. We have heard a lot of stories in different spaces, whether you talk about code leakage, IP leakage, wrong recommendations in a risk area. So I was talking to quite a few presenters here yesterday night, and their view was in a low-risk area, customer support, even mental health as an assistant. These are being adopted at this point. High-risk areas are still being avoided, and a lot of that has to do with what you talked about in terms of how do we govern it? How do we make sure that the recommendations are right? How do we make sure that the data that was referenced for recommendation is right? How do we control access to that? Because the data can get leaked through the natural language. Given natural language processing through Gen AI is basically exposing AI to a lot more users than they used to be, right? It used to be through tools, used to be through people who specialize in AI and machine learning, but now anybody in the world can ask the questions. That means the exposure is much bigger. That means your risk area becomes bigger.
That makes a lot of sense. And how do you see that varying across industries? Are there particular use cases you see in life sciences or financial services?
Yeah, absolutely. So across the industries, the first adoption is in a low risk area, more in an advisory space. Retail, customer service is probably one of the very common one. Amazon Connect, we have seen adoption of that big time on that. Code generation, I think the last speaker talked about it, is becoming big. The amount of heavy lifting that we needed to do, the shortage of coders in different specialized area has created that demand. So we see Amazon Q being adopted big time in that. as I said, in the healthcare, um, the medical coding area is picking up because the risk is low. If you have a wrong medical code for invoicing and billing, not a huge, right? Mental health advice, again, you won't take medical prescription out of that. It probably won't recommend medicine yet, but advice in terms of, as models are picking up on the EQ side, advice in terms of, okay, fine, what should you do? Can you interact? Is there a handy psychologist that we could talk to? Things like those. Financial, what we have seen is um, portfolio management as advice. We have seen growing in that. The other part that we see is more of summarization of 10Ks, the financial reports and things like that. So those are some areas where we see, again, less risk, huge amount of data. You want to extract information, first round of adoption there.
Yep, makes sense. What are some of the challenges or top priorities, bottlenecks that you're seeing with your customers?
So as I said, the risk is on everybody's mind.
Yep.
When model first came in, a lot of models were just giving you answers without telling where the data is coming from. While chats were great for that, enterprises got a little freaked out with that. Like, okay, I don't know where that information is coming from. So second generation of models started picking up on with the data sources. Like, okay, these are my data sources. The challenges that started happening were, even if I know the data sources, and this data can be coming from 10 different sources. One thing that I wanted to call out was, before GenAI or NLP became popular, the data governance and data access was more limited to structured data and semi-structured data, which you can define. Expand that to GenAI, where almost all the data, or most of the data, I shouldn't say all the data, is unstructured. How do you pull information from that and make sure that that you have data, metadata and data governance attached to that? That has become a very interesting topic. It's a GenAI problem, and GenAI is trying to solve it too through a lot of GenAI tools like Amazon Comprehend and things like that, which can read through unstructured data, give you the information. Actually, I was talking to Dreamio at the booth, and they said, one of the information we want to do is extract information from unstructured data and structure it. Okay, interesting concept, because the view is that once you pull information from unstructured data, whether it is audio, whether it's unstructured text, and drop it in a warehouse or an ice house, you suddenly have huge amount of use cases that you can satisfy with that.
Yep.
So yes, the addressing of unstructured data is one of the risks that we are looking at. It's a problem with GenAI, and the solution also is embedded in GenAI itself.
Yeah, I mean, just digging a little deeper on that, it seems that authorization piece, that access control piece, seems like a really important part of the overall effort to work with the LLMs, create your own LLMs, train LLMs. What are you doing from an Amazon perspective to help users with that?
Thank you. Since last 2023 March, a whole lot of evolution has happened in that space. If you look at LLM, first of all, LLM itself, having a control over LLM, not a publicly faced LLM where you put in the data, you don't know where the data is going, right?
Yep.
So training LLM in your own space, in a private space, is one thing that we have done with Bedrock. You can copy or create a private space of your LLM, fine-tune, and then that is something that is over private link. You're basically sending data to it. It sits in your private space. It doesn't share data with anybody else. So your learning is your learning.
Yep.
Businesses love that. The second part is extracting data from an access perspective. So you have data that is sitting in relational databases. Great. Access control is already there. Semi-structured access control is there. More or less graph, access control is there. Here is a huge amount of data sitting in a bunch of text or audio file or images. What do you do about that? We are using, again, as I said, we are using GenAI to control that, to have the metadata and governance over that. Amazon Comprehend we are using extensively for that, to pull data, understand the data, and then tie it together with what we call as entity resolution. So you can tie the data from the structured database, whether it's your transaction data or customer data, and the data that may be sitting in your 10K or sitting in an image, you can tie all these together through what we call as entity resolution, which basically says, okay, fine, here are the data, but all this data mean the same thing. Then the other part is the initial issues that we had with LLMs. You ask the LLM the question, okay, you control the data at the input point with the databases. You understand the data and tie it together with metadata with entity resolution. What about the output side? You want to make sure that some of the data is so embedded in LLM that it's not data that's coming at the inference time. It got into the LLM at the time of training. What do you do about that? That is something that we have with Bedrock guardrails. So it understands the prompt that you're sending to it. It basically checks the prompt part to make sure that the prompt is not something that you're not supposed to ask. And then at the end, when the output is coming out, it checks the output to make sure this has all the content that you're supposed to ask and not the content that you're not. In some cases, it can blank out those answers. In some cases, it can just deny you the answer.
Yeah, that makes a lot of sense. So controlling the inputs and the outputs. On the point of controlling the inputs, that's a question that people often ask me because Starburst and Trino are a federated query engine. They'll ask, should we do federation or should we centralize?
Right.
And
I was going to ask you that.
Yeah, sure. Yeah, I mean, our view is both, depending on the use case. There are certainly great examples where you want to go direct to the source, query the data where it lives, and then there are going to also be reasons where you want to centralize. For example, for performance, if you're going to be querying something over and over again, we would say centralize, and that's where something like Iceberg and the Icehouse makes a lot of sense for you because that's going to be the most economical, best cost performance centralization strategy. But having the ability to do both, offers a lot of value. And the key thing, back to this, managing the inputs, is the access control needs to be enforced regardless, right? Whether it's centralized or federated. And that's been a core part of our architecture, is making sure that you have fine-grained, like row-level, column-level data masking, very fine-grained access controls, both when you're federating as well as working from centralized data in Iceberg. So
this is going to be phenomenal, and I look forward to working together on that because in Icehouse you have data that is structured, you have data that is semi-structured, and you have data that is unstructured. Now, extracting all that information to put the metadata together. So we have some of the tools that we talked about, comprehend, entity resolution, and so on and so forth. To pull that all together and represent it in the central metadata catalog over which you can provide access control is going to be phenomenal.
Yes.
Look forward to that.
Yeah, completely agree. What are some of the solutions available today and perhaps on the horizon to accelerate adoption and development of these use cases within the AWS ecosystem?
Quite a few things are happening, as I talked about. All these that I mentioned in terms of using the AI capability to understand data and relate all that data together. That's one part of it. Recognition, comprehend, entity resolution are some of the things that are maturing. The one thing that I didn't call about is, this happens a lot. When first time last year, Gen AI came out, it was like, okay, one model can do everything. Theory was that large language models are large enough, they understand everything in the world, they can answer all questions. Over a period of time, we realized that that's not necessarily true. Some of the models, smaller models, Mistral, some of the models which are not as big as Cohere's model, they are enhancing themselves depending on the application. There is one application, RAG, where you pick the real-time data. The problem becomes more of how do you train people on prompting? The prompt, and then the whole prompt engineering as a discipline itself is emerging, where you're saying, okay, here is how you prompt it and you get the better answer. Here is how you prompt it, it may not get a good answer. I think if we wanted the language models to become a friend of common users, then we need to take off the responsibility of prompt engineering from common users and put it to a tool. So Cohere does that they have something called Command R, where they take the prompt, they split it out, they know exactly what gives the answer, do a feedback loop and say, okay, fine, this looks like the right model and right answer. So the point was, for different use cases, you have different models which do well. How do you compare? Again, back to, do you want to give it to a data scientist or ML engineer? Do you want to give a capability of that to end users? So we have FM Eval as a tool coming out. I think it is in preview now. It might be coming out now. It's not a paid service. It's just there. So you know as an end user, based on your use case, what model to pick up, which model gave you the best answer. Not about, okay, standards that are published and so on and so forth. You might have something very specific about your data. So we are looking at understanding the data in a structured and unstructured fashion. We'll start looking at tying this together. We are looking at the hardware infrastructure. We have inference here, Trainium and others coming out to reduce the cost of training or fine-tuning.
Yep.
I think you called out about the lack of hardware resources that could possibly happen because of this.
Yep.
So we are working on the hardware side, making sure that the privacy is intact with the private link over Bedrock. We are trying to understand the data. We are trying to do a metadata structure around that. And we are looking for partners on that. So I'm definitely looking at Starburst in terms of handling the metadata part. And then finally, the access control of it. I think as we stitch all these together, we have an enterprise-ready answer.
Yeah.
Right now, depending on where you are, some of the answers are there. That's why people are going, enterprise at least is going at a high-risk implementation, low-risk implementation of that. Once we stitch all pieces together, it will be a high-risk implementation that will be useful.
That's great. And I think, just to put things in perspective for the audience, for those of you who saw Ben Stansel's talk maybe 20, 30 minutes ago, he sort of, tried to point out where we are in the AI hype curve, which is to say we're high on the hype part of the hype cycle. And there may be some, short-term crash, but the key thing is that we're in the very earliest innings of this whole thing, right? Like this is going to be a multi-decade revolution. And I think like the very tangible aspects to focus on today are laying the right foundations for your AI strategy.
So right. I think one of these, somewhere in McKinsey, somewhere I was reading, if you don't have your data architecture, data model, data governance in place today, when you are really ready to solve all enterprise problem with Gen AI, you will find that you have a long way to cover before you can hit really the Gen AI part. So it is, considering that we are early in this stage, it is time to kind of have all those things stitched together.
Exactly. Totally agree. Great. We've got about 5 minutes left. What are some of the top priority areas to fix or build when you're first considering AI development?
This is a wow question because the more number of people I ask who are in their data journey at different stages, the more I think a lot of us have to do. One is database part is fine. Relational data we have had for a long period of time, that's fine. Non-relational data, companies are at different stages. Something like documents have been popular for quite a while. People have started understanding and controlling access control and metadata architecture, metadata extraction out of it. The graph is a relatively newer one. We see enterprises maturing in that and having access control over that because that becomes very interesting. You don't have just the data. You have interaction between data that you're trying to control. The meaning of data comes out of interaction and that path you're trying to control. So that is a different way of access control that enterprises are working on. And then, as I said, now you have this whole new set of unstructured data, document, audio, video, images. What do you do? I mean, how do you find that your logo has not been used by somebody else on the internet?
Yep.
I mean, you have agencies, we try to do that, but doing it in the most efficient way that requires almost like tying all these metadata together and say, okay, fine, who is the user of it, hopefully with a lineage.
Yep. No, I agree with all of that. I think that's exactly right. Getting the governance right, getting the metadata management right. And, I think the other thing is, your models are only going to be as good as the data you train them on,
absolutely.
Right? Garbage in, garbage out. So, access to the right data in a governed way. And then, again, I think not to be understated, just getting your cost performance, just right. Because these are all very data intensive, processes that you're about to embark on, and you're going to want to get the most bang for your buck.
Absolutely. I mean, the model training is something that has become such a difficult task at this point with the large language models that many companies, if a startup, it's extremely difficult for startups to do a model training and large language model training. That's why you see like $10 million, $15 million, $20 billion worth of investment because language models do ask for that. Optimizing that is going to become a very important part of it after that.
Exactly. Well, exciting days ahead.
Yes.
Thank you all for joining us. Thank you so much, Subodh. Really appreciate it.
Thank you very much. Congratulations.
And enjoy the rest of the show.